This is the second part of section 11.4. We're going to do one page of final exam review problems, and then we'll do another page of review problems finding slopes and tangent lines for polar curves. So all of this is review. I suggest you pause the video, yes, and do this whole first page on your own and practice good notation, pretend that you were going to have to turn it in at the end, and then come back and watch. Okay, first problem. Whenever we see cosine squared or sine squared, we need to use the half angle formula before we can integrate. So this is equal to the integral of 1/2 plus 1/2 cos, and we double the angle, 6x dx. You have to know the half angle formulas for sine and cosine, and then go ahead and integrate. So now it's a piece of cake, 1/2 x, then it will be plus, we bring out a 1/6, so 6 times 2 is 12, sine 6x plus c. Okay, so these problems on this page, they're all powers of trig functions. So that's what we're focusing in on here. The next one is a definite integral, and it's a combination of tangents and secants. And so the strategy when you see powers of tangents and secants is to either pull out a secant tangent, and that will be your du, or pull out a secant squared, and that will be your du. Well, if you pull out a secant squared as your du, secant squared is the derivative of tangent. That would mean we'd need to turn all of these into tangents. That's not going to happen because the power of secant is 1. So this isn't going to work. So we're going to go over here. If secant tangent is du, well, that's the derivative of secant. So we have to turn everything over here into secants. Well, that's easy. It's already all secants. So let's just let u equal secant x. Du is secant x tangent x dx. So we have the integral of u squared du. Now let's change our limits. When x is pi over 4, u is secant of pi over 4, which is root 2. Secant is 1 over cosine. And then when x is pi over 3, secant of pi over 3 is up here, cosine is 1/2, so secant is 2. There's our new integral in terms of u. So we've done the first part, rewrite as an integral in u with new limits, and then evaluate. So now we'll evaluate. 1/3 u cubed straight bar root 2, 2, which is 1/3, and then 2 cubed is 8, and root 2 cubed is 2 root 2. And that's our answer. Okay, next one is also powers of secant and tangent, but there are no tangents there. So pulling out a secant tangent as a du is going to be impossible. So let's try writing this as secant squared times secant squared. And the secant squared, this will be our du. Secant squared is the derivative of tangent, so that means we need to turn these secants into tangents. The way to do that is with the Pythagorean identity, that 1 plus tangent squared is secant squared. Now I need parentheses because all of that is being multiplied by secant squared x dx. Now our u is tangent x, and our du is secant squared x dx. So this is the integral of 1 plus u squared du. Now, as I integrate, I'm going to back substitute. The integral of 1 is u, but u is tangent. So I'm just saving myself a step here. Tangent x plus the integral of u squared is 1/3 u cubed. 1/3 u is tangent, so tangent cubed x plus c. All right, and oftentimes I skip that step of, plugging in u and then switching back to a trig function when I'm working with trig functions, because these problems can get a bit long. All right, and the next one is powers of sine and cosine. So the guiding principle here is if there's an odd power, then you can cull off, in this case, there's an odd power of cosine, so we're going to cull off a cosine and turn everything else into sines. So sine 4x, cosine squared x, cos x dx. Now I can turn these cosines here into sines by using the Pythagorean identity. Cosine squared plus sine squared is 1. So this is the integral of 35 sine to the 4th x, and then cosine squared is parentheses 1 minus sine squared, and then I've got my cos x dx. You have to use parentheses there, it's not optional. Now I can multiply this all out and then do the u sub, but I think it'll be less writing if I do my u sub now. U is sine x, du is cos x positive dx. So now I can replace everything and then I'll multiply out. So this is 35 u to the 4th times 1 minus u squared du. Okay, and so before I integrate, I need to distribute. So this is the integral of 35 u to the 4th minus 35 u to the 6th. And now we're good to go. As I integrate, I'm going to back substitute. Everywhere I see a u, I'm going to replace it with sine x. So I bring down a 1/5. 35 over 5 is 7. U to the 5th, that's sine 5. Sine to the 5th, x. Then minus, bring down a 1/7. 35 over 7 is 5. And then we'll have sine to the 7th, x plus c. And there we go. Okay, I'll finish it up with another video so this doesn't get too long.